Hello everyone, welcome back to this video. In this video we are going to complete our lab experiment 3. So in the previous video I have discussed open system call, read system call, write system call and close system call. So I will quickly demonstrate again these system calls and then I will also demonstrate the lseek system call. So lseek is very useful system call. We use lseek to reset the, you can say, the file position. So when we open a file and the file is having, let's say, 100 characters. So if you open a file either in read mode or write mode, and after opening, if we want to read the file, by default we start reading from the very first character of the file. But sometimes it depends upon the situation. If we don't want to read a file from the very first character, let's say I give you a task that write a C program and read a file and print, let's say, from 11th character till 20th character you need to print. Then you need to use lseek system call. So you reposition your pointer from the initial place to some other specific location, and then you can read by using the read system call, right? So let's check how this works. So I'll write a sample code, let's say. I'll show you the manual of lseek first. So if you check the manual of lseek, it is a system call. It is displaying the manual section 2 and reposition read write file offset. So it read write file offset, it can reposition. Initially it is by default at the very first character, but we can reset it. Okay. If we want to use it, we need to include sys/types.h and unistd.h. And it requires 3 arguments. So the very first argument is file descriptor. You know that you get the file descriptor by using open system call. And the next is offset value. Offset value is an integer. It can negative and positive also. So in the first position, if you want to move ahead, like any further positions, if you want to set, you will give the positive value to your offset. But in case your file pointer is at somewhere else rather than the initial position, let's say at the end of the file, then you want to shift it backward, then you will set the offset value as negative. And whence is one of the argument we pass where we can set the current location or current offset value. So if you set the whence value seek_set, that means you want to position your offset as the very first character, like reset. So wherever the current position was, if you set the whence value seek_set, your location will shift to the very first character. And if it is seek_curve, that means wherever the file pointer or the location is available of offset, it will be there and the offset will be added from that particular location, right? And the seek_end, the seek_end means you shift your current position or the offset value of your file to the end, right? So let me elaborate further and then we write the code. Okay, so let's check it. So let's say you are having a file and your file is somewhere created and file is having some number of characters, right? So let's say this is your file and in this file you have stored some data. So you are having data like you have written apple here, let's say mango, let's say 1 2 3 4 5 6 7 8 9 10 and so on. There are a number of things you have stored. So when you use, let's say, open system call and you pass this file as, let's say, a.txt file. So if you pass this a.txt in this open system call and you open this file in, let's say, read only mode, o_rd only. So if you open this file by using open system call and you take an integer like fd, so I'm taking an integer value, let's say fd, a variable, I can store the return value of open in the variable fd. Open returns the file descriptor, as I have elaborated in the previous video. What is file descriptor, you know now, right? So that file descriptor is available in fd now. If I want to read this file, I can use read system call, right? So if I use read system call and if I give this fd, if I want to read and store inside a buffer, I need to define. So let's say I define a character buffer. So I'm giving, let's say, buff, and the size of buffer I'm assuming it is 10. So I use the buff here, and let's say I'm reading 10 character. By default, what will happen when I read it, in this buffer 10 characters from the beginning will be stored. So let's say this is the very first character, second character, third, fourth, fifth, and there may be a new line here. So let's say fifth and sixth, seventh, eighth, ninth, and 10th. So from A to G will be stored in this buffer, right? Right? So the 10 character will be read, and if you want to print this particular thing on the screen, you can use write system call. So you use the write system call, and you can write maybe on a screen. So a screen has having file descriptor as 1, and you can print whatever is stored in buffer, and let's say you want to display 10. Okay, so in that way you can read initial 10 character from this file and write those initial 10 character on the screen. But let's say if I don't want to do that, I want to read like from the 11th character. This is the 11th character, and I want to read further 10 character. So before I start reading, I need to use lseek. So how do I use lseek? I use lseek here, and in lseek I will use file descriptor which I want to reposition, and offset value, let's say I take offset value as 10 because I want to shift 10 values, and 11th character I want to read, and instead of whence we write seek underscore, because I am just shifting this from the beginning, so I will use seek underscore set. Set means in the beginning. So from the first place, the beginning, you add 10. So if you are here and you will 10 shift, if you will do 1, 2, 3, you will reach out O, right? And if you now start reading, actually you start reading from this current position. So now FD is not in the beginning. If you read and store in the buff or buffer, and now you read 10 character, that means you are reading character from 11th character till 20th character, right? So I hope this repositioning you can understand, and the role of seek underscore set also you can understand. But let's say if you want to read the last 10 character, so let's say if I say to read last 10 character, to read last 10 character, so how you will use? You use lseek, and let's say fd is your file descriptor, and you want to read last 10. So what you will do at whence, you write seek underscore, and you reset your pointer or position to the end, seek underscore end, and here you take negative offset value so that you go at the last position and go back 10 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then from there you can read 10 characters. So after this you can apply the read statement, and in read you can pass fd. Now this fd, the position is different, 10 from the last, and then you may use buffer where you want to store, and then if you want to read 10 character, you can read it. After reading, you can write it by using write system call. So write system call, let's see if you want to write on the screen, and whatever the data you want to write, let's say buffer character array, if you want to write 10 character, you write 10. So I hope you must be able to do all these things. Let's have a quick demonstration so that you can understand it properly. Right, so let's write the code by using lseek. Now you can use either nano editor or vi editor in which you are comfortable, or you can use gedit editor also. Gedit is GUI based editor. You can go for it if you are not comfortable with vi. So let's say I'm using nano editor and I'm creating a file like sample lseek. Okay, or demo lseek, whatever you want, .c. Now in this file you can include that which file you are going to use. If you don't know, then you can check the manual for the function which you are going to use. And then let's say you write int main, and in main you write your code. So let's say I'm returning an integer like 0. Okay. Okay, just a moment. Now it is fine. Okay, now I need some integer to store the file descriptor, so I define one integer as ft. If I want to open multiple files, then I use multiple file descriptors. Okay, so I may use, let's say, 2 file, then I'm using file descriptor 2. I'm also going to use a character array, so I use character, let's say, buffer or buff. I can take 10, 20, whatever the size you want, you can take. And you can also define the memory location by using malloc and calloc, so that also you can use to store. That's not a problem. Dynamic memory allocation you can also use. For the simplicity, I'm using just the arrays so that you can easily get it. Now let's say I use open and I want to store the return value of open in fd1, and in open I'm opening a file. So let's say, just a moment, there's a problem, just typing multiple times, so just hold on. File 1.txt, let's say I'm having. Okay, and I'm opening this file in read only mode. Okay, if you are not comfortable with this, you can open the manual of open and you get to know that what you can write here. Remember, I am just setting o_rd only. That means this file must be created earlier. If it is not, then open will return you the error. It is not going to create the file, right? Now once the file is open, if I directly want to read the file descriptor of this open file and I want to store in the memory location, let's say buff, and I want to store the 10 character. Okay, and after storing I want to write on the screen, let's say, so I can use write, and screen means file descriptor 1, and this buff I want to print and 10 character. Okay, so this is an easy to understand code. Now you need to include more header files. If you don't want to include this stdio.h, you can omit this because you are not using printf and scanf. Okay, but you need to use uni std.h. So you can type in your system, right? You can use fcntl also, right? If anything requires, you can check the manual. Sys/types also you may be requiring, so you can use it if it is required. Otherwise, just check it whether it is working or not. If it doesn't work, Right now I am not using fd2, so if you want to delete it, you can delete it, right? So when I will open another file, then I can use it. So in Nano, if you want to save it, you press Ctrl plus X for exit and then press yes to save it and enter. Now I'm going to compile it. So let's use the GCC to compile this code. It is compiled successfully, and let's say a.out. I'm actually using file1.txt, so let's check what is the content of file1.txt. File1.txt is having this content. Okay, it is created in my system, and now I'm running my a.out. Now let's check. Okay, sorry, multiple times t is typed, so okay, it is printing the 10 characters. So let's say this is 1 2 3 4 5 6 7 8 9 10 characters. So it is fetching the first 10 character of the file1.txt. Now let's open the same code and update the code. Okay, so if you open the code again and you update it, now this time I don't want to read the first 10 character, so I use lseek. So before performing this read, I'm writing here lseek, and in lseek I use fd1. I want to reposition this fd1, and my offset, let's say I want to shift 10 character away from the beginning, and because I want to shift 10 character away from the beginning, I use seek underscore set. Set means the initial position. So from the initial position 10 character ahead you are shifting this, and then you start reading and printing this. So this time next 10 character will be printed, means 11th 12th 13th till 20th character will be printed. So let's save it by pressing Ctrl X and Y, and you can press enter, and now compile it again. So if you want to compile it again, you type gcc and then the file name. It is working fine, and then type /a.out and enter. Now this 11th character onward, next 10 character it is displaying on the screen. Now let's say if you want to display last 10 character, last 10 characters are here. You can check last 10 character. So if you want to display, let's modify the value of lseek. So open and check here. So I'm just updating it. lseek, I'm instead of using seek underscore set, I'm using seek underscore end. Okay, and whenever you use seek underscore end, you need to set offset value as negative. Okay, so seek underscore end, and this offset value I'm setting, let's say -10. Now this time I'm trying to display the last 10 character of the file1.txt. So let's save it and compile the code again. So let's compile the code again. Type the gcc and the file name. The code is executed fine. Then type /a.out. It is displaying this time the last 10 character. You can find out the last 10 character it is displaying. Okay, so this is the prime role of lseek. I hope you must be comfortable with lseek. Different tasks can be performed. Later on I will demonstrate you different tasks, but primarily you must be familiar with now how to use open, how to use read, how to use write, and how to use close system call. So let's look at what is close. Actually, this is our responsibility as a programmer to close if a file you are opening. So by the end of the program, if you have opened a file descriptor, better to close it, right? So let me close it. So I'm using close system call, and I'm using fd1 which I have opened. So by the end of the program, I'm just closing the file descriptor so that unnecessarily it should not be opened. Okay, so I hope this program is clear and you understand how you can use the lseek system call, right? So we do some interesting assignment in the next session. For this session, it is sufficient. Thank you everybody for connecting.